Welcome to the video for section I for the AP Calc summer packet, and this section deals with rational expressions and equations. Now, if you remember from Algebra 2 and Pre-Calc, rational expressions and equations is basically the fancy way of saying we're dealing with fractions that contain polynomials. So rational expressions are basically things like this, where you're asked to simplify something like 2 over x plus 2 plus 3 over x minus 1. Now, common sense should tell you can't add these two fractions up, because just like you did in grade school, the only way we can add two fractions is if the denominators are exactly the same, and they're not exactly the same here. So we've got to make them the same. So the concept that we have to do is we have to figure out what the LCM, or lowest common multiple, of the two denominators are. Well, since x plus 2 and x minus 1 are completely different, unique factors, the LCM is just the product of the two. In other words, if I take the left fraction and I multiply both top and bottom by x minus 1, and if I take the right fraction and I multiply top and bottom by x plus 2, I now am going to have two fractions with the same denominator, namely x minus 1 times x plus 2. So that's kind of where we're going to go here, if you forgot how to do problems like this. The numerator for the left will now be 2x minus 2, because we distribute the 2 in. The numerator for the right will be 3x plus 6, for the same reason. And then we just add the tops up, and we get 5x plus 4 over x minus 1 times x plus 2. Okay? That's a basic one. I say basic because I don't have to do any more simplification beyond that. Let's look at one where maybe we have to do a little bit of simplifying at the end. So let's consider 6 over 2x minus 4 over x plus 3. Okay, again, the denominators are not the same, and they're totally different. They don't have anything really in common. So if I take the left fraction and I multiply it by x plus 3, both top and bottom, and I take the right fraction and I multiply top and bottom by 2x, now I'm going to get on my left fraction 6x plus 18 over 2x, x plus 3. And my right fraction will be 8x over 2x, x plus 3. Again, denominators are the same, so I can subtract. I get negative 2x plus 18 over 2x times x plus 3. Now we can actually reduce this. Be careful though. Fight the temptation to just cross out those two x's. You can't do that, because you can only cancel out common factors from the top and the bottom. So the key is going to be to factor the top and see if there's something that I can cancel. Since I have a negative 2x and a positive 18, I can take out a 2 from both terms and be left with just negative x plus 9. Now, the 2's can get canceled, and I'm left with negative x plus 9 over x times the quantity x plus 3. You could redistribute that and make it x squared plus 3x, whatever really you prefer doing, but I would take it in that form as well. Now, let's take a look at what happens when we have equations. Oh, before we look at equations, actually, let's look at one more expression. Let's look at a more complicated expression. Let's look at a complex fraction. Look at something like this. All right, that's easy enough. So what if I now do this? This is what we call a complex fraction, because it's a large fraction in which either the numerator, denominator, or in this case, both the numerator and denominators contain a fraction in themselves. So here's what I do. I look at all four denominators of the problem. I just highlighted. What is the LCM of those four denominators? Some have x's, some have y's. So to make them all common, we have to turn them all into x times y, or xy. I'm going to take that LCM, and I'm going to multiply the four numerators in this problem by the LCM of xy. And here's why I'm only multiplying by the numerators. Look what happens. In the first piece, that x and that x cancels. In the next piece, the y's cancel. In the bottom left, the x's cancel, what just happened. All four denominators of the smaller fractions disappeared. We're left with y plus x over y minus x.
All right, now let's start looking at some rational equations. So here's an example of one. Let's look at something like 1 over p squared minus 4p plus 1 equals p minus 6 over p. And the directions might say something like solve for p. All right. Well, looking at this, there's a reason why I did the complex fraction problem ahead of this problem. We're going to do the same sort of thing. We're going to multiply the numerators of this entire problem by the LCM of the entire problem. So if we look, I've got a p squared minus 4p. I've got really a denominator of 1. This is like saying 1 over 1. And then a denominator of p. So what I want to do is I want to ask myself, what is the LCM of the whole problem? Well, to see it a little bit more carefully, I want to rewrite this first denominator in terms of its factors. P times p minus 4. Now if we look, there's a p that they have in common, so I'm only going to write that once because it's the lowest common multiple. And then there's a p minus 4 that they don't have in common, so I'm going to put that in my LCM as well. Okay, so that's the LCM of the entire problem. So I'm going to take every fraction and I'm going to multiply it by p times p minus 4. What that enables me to do, it enables me to cancel basically all my denominators. And then I wouldn't cancel anything for that second fraction, but I would cancel out the p's. So if you notice now what happened is all the denominators are gone, and we just focus on the numerators and turn this into a more basic equation than one that we started with. So the first fraction just becomes p. The second fraction is going to be p times p minus 4. And then that's going to equal the quantity of p minus 6 times p minus 4. All right, so let's simplify. We get p plus p squared minus 4p equals, we'll FOIL the right, we get p squared minus 10p plus 24. Now let's start to clean things up. The p squareds cancel. We get negative 3p equals negative 10p plus 24. We can bring the 10p over, so we get, I'll do it on the right side here, we get 7p equals 24. Divide through by 7, we get p is 24 over 7. Okay, and that is the solution to that equation. Now the only thing I would caution you about, make sure you do this, this doesn't come up in this problem, make sure you take this solution and plug it back into the original problem, because sometimes we can have extraneous solutions here. Sometimes we can get a value for the variable that makes one of the original fractions have a 0 denominator, which means it's an undefined fraction. Therefore, the solution really doesn't work. Let's just try one more. Okay, so let's look at a problem like this. Let's do 1 equals 1 over x squared plus 2x plus x minus 1 over x. Okay, again, I want to look at the LCM. And I think the easiest way to do that is by taking all the factors for each of the fractions. So if we factor x squared plus 2x, we get x times x plus 2. So when we get our LCM, they both have the 1x in common. The center fraction has an x plus 2, so I got to put that in all my fractions as well to get a common denominator. So x times x plus 2 is what I'm going to use to clear out my fractions. So I'll multiply the 1 by x times x plus 2. I'll multiply the center by x times x plus 2. And I'll multiply the last one by x times x plus 2. Okay, so the middle fraction, the entire denominator cancels out. The right fraction, just the x cancels out. And then the left one just becomes x times x plus 2. So we'll clean it up without denominators. I get x times the quantity x plus 2 equals 1 plus x minus 1 times x plus 2. We'll distribute. We get x squared plus 2x. We'll FOIL. We'll get x squared plus x minus 2. We can start to do some combining and canceling. Well, the x squareds cancel. The numbers on the right can combine, so I get x minus 1 equals 2x. I'll bring that x over. And I get x equals negative 1. Again, you just want to double check and make sure there's no issues with either of these denominators here and here becoming 0, and they're not. So I think negative 1 is the way to go. All right. Thank you for watching this video, and good luck with the rest of the work.